In this video, we're going to review how waterfalls are formed. Now, waterfalls are found in a river's upper course, and on the board here is a diagram of a river's long profile. It shows the river's height above sea and the distance from the sea, so the distance from the mouth, the end of the river that goes into the sea. We can divide this up into three imaginary sections: the upper course, the middle course, and the lower course. In the upper course, near the source of the river is high above sea level, and it is a long way away from its mouth where it flows into the sea. In the middle course of the river is still fairly high above sea level, but less high above than in the upper course, and it's closer to its mouth. In the lower course, the river is almost at the level of the sea, and it's much closer to its mouth. Now, waterfalls occur in the upper course, so they're in the river in the upper course. It's high above sea level. It's in an upland area, a hilly area, and it's close to its source and far away from the river mouth. Waterfalls are formed by erosion. Tell your screen what erosion is. Well done if you said that erosion is the movement of rocks and soil, causing them to break down. Waterfalls are formed when there are two different types of rocks on the riverbed, so at the bottom of the river. We have hard rock and soft rock. So here is our soft rock, and here is our hard rock. Tell your screen which rock will erode faster. If you said that the soft rock will erode faster than the hard rock, that's brilliant, well done. So the soft rock is going to erode faster. It's going to be broken down by the movement of the river above it, and it's going to erode. So here is our soft rock, and here is a section of soft rock that has been eroded by the river. Let's draw the river flowing over the top of its riverbed. Oh, when it gets to this point, it's going to have to flow downwards because the soft rock has been eroded here. As the river is flowing downwards, what's going to form here? Tell your screen what forms at the bottom of a waterfall. Well done if you said plunge pool. Let's draw in a plunge pool. So the water has flowed over the soft rock that's been eroded, and a plunge pool starts to form. Here, at the bottom of the waterfall, is the plunge pool. And the river, it's still flowing over the waterfall. It flows into the plunge pool, and then it flows away from the waterfall. Over time, this plunge pool is going to get bigger. What will cause the plunge pool to get bigger? Tell your screen. Well, erosion is going to make that plunge pool bigger. Remember, the plunge pool is being formed from the soft rock. The soft rock is easily eroded, so the plunge pool will get bigger over time. Will attrition form the plunge pool? Tell your screen, yes or no. Will attrition form the plunge pool? No. Well done if you said no. The plunge pool is not going to be formed by attrition, because attrition is when the load that the river is carrying is smashed together and gets smaller. Attrition happens on what the river is carrying, not the bed of the river. Tell your screen what forms of erosion break down the river bed and the river banks. If you said hydraulic action and abrasion, well done, they're the correct answers. So hydraulic action happens in the plunge pool because the force of the water flowing over the waterfall erodes the riverbed. Abrasion happens in the plunge pool because the river carries with it a load which contains rocks. And those rocks scrape against the side of the plunge pool, making the plunge pool larger, and we call that abrasion. Eventually, the plunge pool gets bigger, and it gets so big that there's nothing underneath the hard rock on top. Look at this section of hard rock here. There's no soft rock underneath it. Tell your screen, over time, what will happen to this hard rock now there's no soft rock underneath it? If you said it's going to fall down or it's going to collapse, well done, that's the correct answer. We call this area of hard rock, when there is no soft rock underneath it, we call it an overhang. And over time, the overhang collapses and the rock falls into the river, and the river uses that rock for abrasion to make the plunge pool even bigger. So let's make our plunge pool even bigger. It's being eroded over time by abrasion and hydraulic action, and it's got bigger. And can you see now that there is a new overhang? And eventually, the plunge pool is going to get bigger again by erosion. The overhang will collapse and fall into the plunge pool. So what's happened to our waterfall? Well, our waterfall started over here, but now it's moved backwards. Our waterfall is now here. So let's get rid of our old waterfall. And we're just left with our waterfall here. In geography, when a waterfall moves backwards, we say that the waterfall has retreated. You might have come across the word retreat in history. If you have two battling armies, it's one army, here's the other, and this army, they're a lot stronger, there's more of them, they're winning. Well, this army will start to move backwards, it will start to retreat. So retreat means to move backwards, and you might use it in history to describe armies, but in geography we use it to describe when waterfalls move backwards. Due to erosion and the retreat of the waterfall, waterfalls carve out a gorge. Here is my attempt at 3D drawing. So at the top of the gorge we have the waterfall, And a gorge is narrow, very steep-sided valley that is formed by the retreat of a waterfall. So the waterfall used to be here, but over time it's retreated, it's moved backwards, and it's left behind a narrow, very steep-sided valley called a gorge. There was one other thing that we needed to go over from last lesson, and that was, why is the valley V-shaped in the upper course? We know that rivers flow in channels. Channels are the wet bit of the river, that's where the river flows. And around the channel is some land. And that land around the channel is called a valley. In the upper course of a river, the valley is very narrow and has very steep sides. We call that a V-shaped valley because it looks like the shape of the letter V. In the middle course of the river, the valley gets wider. Here's our river channel, here's the valley around it. And we call it a U-shaped river valley. In the lower course of the river, the land is almost flat. So there's our river channel and there's the land around it. So why is the valley V-shaped in the upper course? Well, if we go back to our diagram of the long profile of the river, near the source, in the upper course, the river is very high above sea level. And the water wants to get to a lower height. It wants to be here at the level of the sea. So instead of eroding sideways, which we call lateral erosion, in the upper course, the river erodes downwards, it erodes vertically. And because it erodes downwards, it makes the land around it V-shaped. Well, how does that work? Let's say that we start off with our river, and it's on flat land. Then the river erodes downwards, it erodes the land around it, and it creates that V shape with the river flowing at the bottom. In the middle course and in the mouth, where the river is much lower, it's more closer to the level of the sea, the river erodes laterally, and that makes the river valley wider, giving us that U shape and eventually the flat land in the lower course.